Alright, so kind of like Laplace and inverse Laplace, we're going to introduce a new type of function called the unit step function. You've probably seen the step function in earlier math courses. That's the one that, well, yeah, let me pull up a picture real quick. Okay, so I thought it'd be a real quick distraction just to say, hey, you've seen something like this before in math. So sometimes this is called the floor or ceiling function, where your y value is a certain value until you jump up to the next step, and then it's just that constant value there. So we're looking at manipulations of this type of function. Okay, so unit step function, either our y values are 0 or 1 up to a defined transition point. And then in general, we can define a general piecewise function where there could be any two different functions with those parameters there. Now, when we have those parameters, we're going to sort of convert this using that same logic from the transformation of the Laplace functions, in that our the unit step function, this fancy u t minus a, where a is defined by that transition value on the x-axis. Same thing here, where we absorb those parameters in with the g and h function, essentially convert this complicated piecewise function into essentially a linear function that we can eventually manipulate. And we can look at this even in more complicated examples. So if we have, say, something like this, where you've got three pieces, so 0, g of t, and back to 0 again, and the parameters go from 0 to a to b, and back to b again. Well, the 0 piece is essentially timesing by 0, so we're really focused on that g of t piece. And so in the g of t piece, you can see that our transformation is t minus a and then t minus b, just in that general format. So we're going to use this general format to find ways that we can rewrite functions in terms of the unit step function. Okay, so f of t is 20t from 0 to 5, and then 0 from after 5. So what would that look like? All right, so f of t, again, just following that pattern, would be 20t minus 20t times the unit step function of t minus 5. And then what would a graph of something like this look like? Well, let's see. At 0, the y value would be 0. And 5 is where it gets interesting. So up to the number 5, 20 times 5 would be 100 up here. So up to here, an open circle. And then after that point, and this would be kind of hard to see, but you have a flat, your function would be just flat 0 at that point. Okay, so let's let me recenter this. So let's make a connection here. So we have this idea of a transformation, and then we have this idea of a unit step function. So t minus a would be from 0 and 1, and then a t greater than or equal to a. Okay, so let's kind of think about what those two elements put together represent. Okay, so let's look at f of 1, just f of 1 itself. So if we say f of t equals 1, then f of t minus a should also equal 1, which means f of s would be the Laplace transform of 1, which would just be 1 over s. So if I do the Laplace transform of the unit step function, of t minus a, then remember that Laplace of t minus a piece, that a is just a transformation in terms of e. So that would give me e to the negative as over s. So if I'm asked to do some sort of unit transformation and I can figure out what a is going to be the exponent of e, and the other numbers simply tell me the exponents of e themselves. Okay, so the new critical thing, and I want to emphasize this right here, is this little definition for us right there as we go forward and look at Laplace transformations of unit step functions. Okay, so find the Laplace transform of the given function. So I'm going to do the Laplace of f of t which is going to be 2 times the Laplace of 1. So that's that 2. I'm just factoring the 2 out and looking at Laplace of 1. Okay, then that 3 factors out, and it's the Laplace of the unit step of t minus 2, and then we can kick in that other definition that we just learned about, plus, there's nothing to factor on that last one, so it's just the Laplace of u of t minus 3. Okay. All right, so that then says we got 2 times the Laplace of 1 is just 1 over s, minus 3, and then that Laplace of the unit transform of t minus 2 is just e to the negative 2s over s, and then that last term is again a unit transform of t minus 3, so that's e to the negative 3s over s. So I can clean that up a little bit. So 2 over s minus 3e to the negative 2s over s plus e to the negative 3s over s for that conversion.